We've got Mark Rush with us, and he's from General Electric, where he's serving as the Technical Director for Renewable Energy Sales, and he's been there since about 2010. Prior to joining GE, Mark was the Vice President of Program Development at Vestas America, and he spent 12 years in telecom at Lucent Technologies. He also was a private developer in a previous life in Panama and Colorado for 5 years, and he lived off-grid in Bocas del Toro, Panama from 2004 to 2008. He has a master's degree in international management from Thunderbird, a project management degree from the Stevens Institute, and an electrical engineering degree from MSU. So we're really pleased to have Mark with us today to talk a little bit about some of the capabilities of modern wind turbines. Mark.
Hey, Amanda, thank you. Wow, talk about your life summary in 30 seconds or less, but that's definitely been it. And I enjoyed my current life and my previous life. But yeah, so we want to talk about trends in wind, how we can value it, how we can share it with other forms of energy. So first picture, this is northeast Brazil. The trade winds go right past this area. So one of the biggest wind farm areas in the world is this northeast Brazil area. Let me see if I can change the page here. No, I can't. I'll just say next. It's okay. So we can go to the next page. There we go. All right. So last 10 years or so of sort of GE products. So Karin had talked about hub height as well as rotor. Hub heights, they do go higher occasionally. You want to find higher shear areas for greater hub heights. But rotors and megawatt ratings, definitely on the way up. Really, the latest products, say 2014 going into 15, we're into rotors at 120. We've got hub heights into the 140 meter range in Europe. Most of our 2023 products, these are more of the North America products that you think of for, Midwest corridor. Different places like that. But over the last 10 years, we've seen capacity factors basically double. And these would be gross capacity factors, say, in the mid-20s to now up into the mid-50s. You want to take net losses off of your grosses. But basically doubling in capacity factor and doubling in revenue per turbine. So that's what's driving the lowest cost of energy and all the cost curves that Karin had talked about. Next page. So this is kind of looking at what we call constraints versus speed. So in the Americas markets, we typically see megawatt constraints, we call them. Say a 100 megawatt farm, you can put X number of turbines depending on the rating. Where in Europe, it tends to be more land constrained. We have land constrained areas in the U.S. They tend to be more northeast. So this is kind of our index of how we look at different things. Latest North American products are really the ones right there in the center. 20116, 23107. That's really the North America product of choice right now. Next slide. So in terms of evolution of the industry, as I said before, a combination of things have happened. Doubling of capacity factors, bringing availabilities has been a key part. When I started in the industry 7-8 years ago, gearbox problems, lots of machine head type problems, whether they be gearbox or generators, which drove poor availability results. And I've worked with a couple of OEMs, so I know that this is an industry problem. But in the last few years, we're seeing 98% availability with GE, as well as I'm hearing that the competition is driving similar results. So, well done for the industry. I think we're really getting not only valuable products, but quality products. And that's also helping with cost of energy. If we can if we can have reliable products that our utilities, our developers can depend on, there's a good value there. And then in terms of PPA rates, yeah, we're getting below 3 cents a kilowatt hour kind of range, $30 a megawatt hour. We see that quite a bit. How do we continue to lower costs of wind? Rotors are going to keep getting bigger. So there's physical assets, something like a rotor, something like a taller tower. There's also software, and so you probably can't avoid GE's campaign on, being a software company, and not only being one, but being a top 10 software company. So we're really geared up to blend in even more intelligence into our turbines because we see a lot of values there. Next. In terms of information, so this is an older page, but basically with the SCADA systems, we're getting a huge amount of data flow per second, lots of sensors all around the turbine, which gives us a lot of loads information, a lot of time and moments information that we can use to perfect how we can push an existing turbine into a higher application space. So we're getting near real-time capabilities to adjust loads and thrust and other items to push some of our existing products into higher envelopes, as well as to bring new rotors into the market and put them into these great application spaces. More AEP, it all translates into lower cost of energy. So next. So as far as wind is a good citizen of the grid. The U.S. we're coming along. I'm sorry. Okay.
You're fine.
So,
you're fine.
Okay, thank you. All right. So for the U.S., we're coming along. Excel is sort of leading the pack in terms of our utilities of blending wind in. I saw a 61% mark that we hit at some point here in the last 12 to 18 months. I think it was probably 12 months. But if we look to our European friends, Denmark has already done over 100% of their power needs from wind. Portugal, Spain, Germany, they're all doing it. They figured out how to blend in wind and take advantage of free fuel. So how do we do that? We use our weather forecasting systems to understand how our resources coming to us. For the U.S., the weather tends to come in from the west and head to the east. And we actually have very sophisticated models to figure out, what that resource is going to be in the 15, 30 minutes, day ahead, sort of calculating spaces that we need to take advantage of that. We have a sense of what our resource needs are going to be. We have a sense of, what are the resources that are coming our way. And with high capacity factor turbines, when we're getting turbines that are fairly predictable, we have a real sense of how much energy is going to be coming in time. We can really use that to thread into our energy model and blend in as much wind as possible. And some of the European countries are getting very good at that, and we are fast following. Next page. So in terms of plant controls, I was asked to talk about how we can do generation control. So there's a couple of different aspects there. Number one is forecasting. So I talked about predictability of the resources that is coming that way, that is coming our way. How will those resources affect turbine A versus B versus model X versus Y? That's just math. So we can actually do a fairly good job today at short-term predictions. In terms of power controls, so we can look at ramp rate limitations, the governor response, using the inertia in the turbine for things like frequency or voltage controls. We have the capability to overspeed them occasionally if we find some advantage there. So there are any number of curtailment versus regulation methods that we have to control individual wind turbines as well as a wind farm as a common unit. So we have controls at parent or child levels. In terms of voltage controls or frequency controls, we have the same capabilities. We can look at, droop compensation, any kind of line drop compensation, plant communications, VARs as they're needed. We have power factor settings that we can apply so that things are responding real time to basically manage a smooth curve. In terms of stabilizing following any disruptions, so we have ride-through capabilities, whether those are high voltage or low voltage ride-through capabilities. And all of those items can be managed not only at a plant level, but they can also be communicated to the grid operator as far as, here are the events, here is the response, here's the expectation. And, I will say the nice thing about General Electric is it's an electric company with a wind option. So they're already very good at this, and now they're actually very good at wind now as well. Next. So predictable power from wind. That's kind of like any renewable energy. That's always been our Achilles heel is, the sun doesn't shine, wind doesn't blow, things like that. Well, we've been using batteries for about 3 years. And by using, I mean, we've actually installed batteries adjacent to wind turbines and been doing field studies for several years now, not only with different battery types, but different configurations. And what we're learning from this is that we can create, in effect, a buffer capacity to make the wind more predictable for, say, a 10, 15, 30-minute period. We have the ability to commit power for different time periods, and we can close down what the standard deviation would be without those plant controls. So there on the right, you're seeing a deviation of 6 positive or negative to a mean. With batteries, we can effectively close that for specified periods. Next. Excuse me. So storage does a couple of things. Not only does it help us with time travel, but it also helps us with smoothing power out. So we can perfect the frequency needs in case there are any adjustments in the grid. We can use batteries to also compensate for that, as well as we can use the batteries with some of the ramp rate controls. As maybe there's a power need on the grid, the wind is down, we have the ability to provide some power while the turbines are coming online, as well as the ability to smooth in different situations. Next. And I'm saving most of the time, by the way, for questions. So smarter machines, we're all in terms of sensors and software. In the past, we've had pretty good sensors, pretty good model-based controls, but they've all been responding to events. We're now getting better at what we call virtual sensors and smart responses, and those smart responses can be a full shutdown to prevent some extensive damage, let's say, or to make a situation much worse than it otherwise would be. So we're getting much better at that. The future is all about what is the resource coming to us, and so we're using LiDAR and blade sensors to understand the resource that is out in front of us and how we can go ahead and prepare to sort of embrace that resource and maximize that resource. And again, we look at things at an individual turbine level, or a turbine as a collective. So again, parent or child responses we find are valuable in different scenarios. Next. So what we're calling our brilliant technology is, again, extending software into this parent-child relationship of wind turbines. So we've got storage capability that can be used with the converter and the controls within the turbines. We have the ability for the turbines to share information, to share, say, what's happening with the front line of a wind farm that's going to be coming through the wind farm, and how that can make a predictable adjustment to the subsequent lines, let's say, of the wind farm in the direction of the prevailing wind. We have the ability to do, any kind of controls we need. We can do noise management in terms of, adjusting the blades, adjusting the speed to manipulate the acoustic output. If we have a need for time of year or time of day, we can control that at a individual or parent level. Wake management is one of our latest success stories, I guess, and we're talking about as a wind farm, the wind is coming through in a certain direction. That's creating a wake effect through that turbine. We can predict what that wake effect would be, and we can adjust the turbine behavior to maximize the output of the wind farm at all times. So there are some tricks in doing that that we found are beneficial. Next. So sort of putting it all together, you've got integrated data and real-time analytics that are all happening. We've got 28,000 turbines out there, 120 sensors per turbine, 900 signals per turbine per second. So there's a massive amount of data flow that's occurring. We filter that data for what's the material versus the immaterial data. We have algorithms that we can apply to that. We have analytics that can give us sort of a red, yellow, green traditional output, or add a social media element to that. Put it to your smartphone, and you've got you've got some great analytics. You've got some great responsiveness from the people in the field as well as the back office experts. You have the ability to predict that event, what are the possible outcomes of that event, what controls do you apply to minimize the outcome of that event, and then you would modify and adapt your controls for that situation. That's a continuous feedback loop as we learn from, say, one type of farm or one model or vintage or one part of the world or one electrical or grid condition. We're able to tag those and use those to fill our library of lessons learned and responses. So there's a great feedback loop. There's great tools for applying lessons learned. Next. So the digital wind farm is something that we came out with at, I think it was AWEA in May. And so the digital wind farm is sort of putting it all together, putting sensors, intelligence, creating what we call a digital twin. So we have a replica of a wind farm, the models, how that wind farm is built, and then from that we can apply different criteria to that and predict how that wind farm will behave. We can apply loads. We can apply different scenarios to understand how much can we really stress this wind farm and sort of tease the value out of the wind farm, as well as do we have opportunities to introduce new technology and still stay within the loads envelope or the permitting requirements or whatever the constraints are for that particular scenario. So this was just a quote through the Harvard Business Review, but yeah, digital wind farm, digital concepts have huge current value as well as huge potential value for us. Next. And I think that's it. Thank you very much.
Mark, that was great. Thanks very much. I want to be able to control or at least see a wind farm from my smartphone. I think that would be pretty awesome to be able to do that. So we are asking people, if you have a question, please on the web raise your hand so we can unmute you and we can call on you, or you're also welcome to answer it in or ask in the chat box. I had one for you, Mark, to start out. Early in your presentation, you had a slide that said that wind availability was 98%. And I'm wondering if you can contrast that for me for other types of energy technologies. So as I take that 98% to mean is that the mechanical availability of a wind turbine is going to be there almost always. Can you give us any sense of how that compares to a natural gas turbine or a coal plant?
You know, I really can't, because I'm a wind guy. I'm a renewable energy guy. Yeah. But in terms of what does availability mean, that means it needs to be available for its duty cycle when the wind comes up.
Yeah. Yeah. Well, that's an amazing figure to me that it's 98%. So. The other question I had is, can you talk a little bit about, you talked about battery storage and some of the tests that you're running on that. How much capability in battery storage are you putting online?
So I work for Renewable Energy. We have a batteries group, we have a solar group, we have a wind group. When we merge with Alstom in a few weeks, we're going to have all kinds of groups. The combination of wind, solar batteries at utility scale is coming now. There have been a few hobbyists. I mean, there are less than 10 farms, let's say, that I know of globally where there's really been something, you know, a huge block of batteries and things that has been applied. But so most of the units are selling a storage block for a particular client need. But we are still getting opportunities where we're seriously looking at different battery technologies to blend into a wind farm. And there are opportunities that are going on today.
Great, great. Okay, I am going to go to Bruce Plank. Bruce, I think your phone is unmuted if you want to ask your question.
Sure. Thanks, Amanda. The question is whether small wind machines are also becoming more efficient and able to produce higher capacity factors.
Small wind meaning like
well, anything
900 kilowatts or less?
Yeah, I mean, you were obviously talking about the very large-scale utility farm scale wind machines, and obviously there's a range of size of machines, and I'm curious if there's development at the smaller end along the lines you were talking about, particularly with increased capacity factor, or if that's really limited to the very large utility scale, utility farm size machines.
Yeah, so two parts to my answer. I kind of personally follow small wind, you know, because I think wind at any scale, I want it to succeed. Professionally, I don't follow small wind as much. I have seen articles more in Europe that I would say were not positive articles about community response and different things. I can't answer your question, though, about capacity factors on small wind. However, for large utilities, they need to be sure that any of their power plants are predictable, that they can depend on them, because the buffering that they need to do to blend in you know, these variable resources is important, and I think Steve has got some of that element in his presentation.
Okay, thanks.
So I've got a question from the phone that asks about, you're talking about a lot of the capabilities that wind turbines have and their sophistication. Who do you think is not hearing that message? Because the Wind Center here and then a number of the advocates on the phone are, they want to make sure that people understand the capabilities. So as you're going through your work, who do you find doesn't really understand wind?
The public, unfortunately. I think this is a very niche-y kind of product. Not as much as before. We have had a couple of booms here in the last 5 to 7 years, which has been great. But there is still a lot of misinformation that's posted on the internet. And unfortunately, that's all the public has access to. So that drives me crazy. And I go to schools. I try to educate. I try to, you know, not just drink the GE or Vestas Kool-Aid at all times. These are, you know, I want to be sure that when somebody goes by a wind farm, you know, they go, wow, that is fantastic. I don't want it to be irritating. And there are still articles on the internet that have been recycled for the last 15 years about their bird killers or their whatever this or their whatever that. And that's really just not the case. You know, they don't have a negative house value effect. I've read, you know, it's sort of myth busting, I guess. A lot of that information is something I continue to do.
Okay, great. So I have another question on the web that says there's a lot of severe weather on the plains, and there's been previous history of problems with turbines, blades, and their strength. Is GE doing anything to strengthen the blades themselves against, you know, severe weather and damage to the blades?
So, you know, I've watched, the answer is no, but we already have design standards that we design to, you know, according to our industry standards. There are always going to be extreme events. When a hurricane decides to come through somewhere, it's going to take everything with it. It doesn't matter what you try and put in its way.
Yeah.
I have seen one YouTube video in my 7 years where a tornado actually hit a wind turbine. I saw it pass by several. And so it grabs the blades and it will throw those blades, you know, half a mile, and it'll tumble around and things like that. But no, we can't design blades for Class 1 hurricanes. The probability is actually really, really low, and there really aren't instances where there are threats to people, quite honestly, and that's our biggest concern.
Yeah.
Everything else is an insurable event.
Okay, great. I've got 2 more questions. Are there any community wind farms like the community solar farms we're seeing more and more of?
You don't see those, and I wish we would. The problem is, you know, these wind turbines, they do put out some acoustics. So you don't want to put them near schools. You don't want to put these in the suburbs. They need to be out in the Midwest. They need to be out in these wide open spaces. That's where they belong. The turbines cost, you know, $2 to $3 million a piece. So there's just, you know, communities have a lot of trouble crowdfunding, you know, those types of dollars. And, you know, we have worked with farmers in Iowa, and, you know, we do have some success stories there. We do help with some 10 and 20 megawatt farms. But there's just an economy of scale that goes with this particular industry.
Yeah, makes sense. Okay. Here's our last one. What information is available about degradation rates for wind turbines? The person asked, there's older reports available, but is there any new public data that you could point to?
Yeah, I would, and I'm not researching that, so I don't have a really good answer. Corrine may actually have a better answer for that. If I'm looking for public information, I'd probably go to NREL, or I'd probably go to an organization like this that is, purposed to seek out and distribute this type of information. I'd probably start with NREL and derive from there.
Okay, sounds great, because what you have is more private. Okay.
Yeah, yeah, exactly.
Okay, excellent. So we are going to go